The big shift this week is that AI is starting to unify modalities that used to live in separate stacks. Biology models that read sequence, structure, and language in one pass, science models that speak a real generative grammar for molecules and materials, and interactive systems that can perceive, think, and javab back in real time without glue code. That matters because every adapter, encoder, and handoff you remove cuts latency, error accumulation, and engineering overhead. What ties these papers together is a move toward native end-to-end models. Keep watching, because the details reveal where the real bottlenecks still are. Let's explore the first paper, Biomatrix towards a comprehensive biological foundation model, spanning the modality matrix of sequences, structures, and language. Biomatrix, built on Qwen 3-in-1, 7B, and 4B sizes, is presented as the first decoder-only biological foundation model to natively unify sequences, 3D structures, and natural language for both molecules and proteins under one next token objective. Its core technical move is a shared discrete vocabulary that combines SMILES, self-i's, residue tokens, and learned structure codes from MolStructTalk for molecules and GCP VQ-VAE for proteins, eliminating external encoders, projection adapters, and modality-specific heads. The model is continually pre-trained on 304 4B tokens spanning text, molecule, and protein-centric multimodal data, plus cross-entity corpora such as bindingDB, crossdocked 2020, and PPI-ref, then instruction-tuned on 24,845,248 examples across 80 tasks in 6 categories. Empirically, Biomatrix reports state-of-the-art or competitive results on 77 of 80 tasks, including molecule captioning and text-to-molecule generation, where Biomatrix 4B improves exact match accuracy from 48% with SciReasoner, 8B to 65.07%, and property condition conformer generation, where mean absolute error on QM9 electronic targets drops from 205 to 53 MeV for HOMO, and from 297 to 81 MeV for the HOMO-LUMO gap. For proteins, Biomatrix 4B reaches 73.78% total accuracy on molecule QA, 90.69% on subcellular localization, 75.5% amino acid recovery on inverse folding, and 0.963 SCTM on unconditional backbone generation. The paper argues that cross-modal gains are largest on tasks that force sequence structure language alignment, while residual geometry gaps largely come from finite codebook quantization rather than the autoregressive backbone itself. Let's explore the second paper, Speaking the Language of Science toward a General-Purpose Generative Foundation Model for the Natural Sciences. Logos, developed by Alibaba Group researchers with Renmin University of China, is a general-purpose generative foundation model for the natural sciences that replaces natural language interfaces with a unified scientific grammar over proteins, antibodies, small molecules, reactions, materials, protein pockets, and protein ligand complexes. The model tokenizes spatial interactions as sequences and trains autoregressively on 44.87 billion tokens, then post-trains on 4 downstream generative tasks. A key finding is that more natural language pre-training tokens hurt scientific performance, while inheriting Qwen 3 backbone weights helps. The full weight initialization beats random initialization on pocket condition ligand design, improving VINA from -6.91 to -7.43. Scaling from 1B to 8B parameters consistently improves performance. Ligand docking reaches a best VINA of -7.76. Retrosynthesis, top one rises to 74.8%. MOF generation reaches 45.19%. Valid, 39.02% VNU, and 17.78% NBB, and protein editing on GFP reaches 0.93 fitness. Logos also generalizes beyond pre-training formats, achieving 85.18% amino acid recovery on CDR, H1, and 85.93% on CDR, L2, while remaining purely sequence-based and often matching or outperforming domain-specific baselines that require explicit 3D geometry. Let's explore the third paper, OneStreamer v0, One End-to-End Real-Time, Interactive Foundation Models. OneStreamer v0, Wang from the Alibaba Group is a native streaming, end-to-end interactive foundation model built for real-time full duplex audio-visual conversation, and its key novelty is that language, audio, and video are all modeled as both inputs and outputs inside a single transformer, rather than through cascaded ASR, TTS, avatar, or video generation modules. The system uses strictly causal audio and video VAEs, causal multimodal encoders and decoders, and block causal attention, so each newly observed unit can immediately affect the next response, while committed response latents become part of the interaction history. Training combines independent task pre-training, duplex interaction training, and distillation from a stronger CFG teacher with rolling distillation and self-forcing to reduce train-test mismatch. At inference, a 2-GPU thinker-performer pipeline overlaps perception, KV cache update, decoding, and flow matching latent generation, producing approximately 200 milliseconds model-side response latency and approximately 550 milliseconds total interaction latency with a 350 milliseconds bidirectional network budget. The paper reports streaming units as short as 160 milliseconds at 25 frames per second and validates the V01 system at a preliminary 192p output resolution, positioning OneStreamer as a unified benchmark for low latency, multimodal dialogue with synchronized speech and visual response. That's a wrap on today's AI paper highlights. Thanks for watching.